Hi everyone, welcome to day 2 for or week 4. This is the first video. Quick recap of where we are at. We've looked at trigonometric ratios with respect to right triangles, and in particular with respect to lengths of the sides of the triangle, right? Sine, cosine, tangent, they were all ratios of the side of the length of the triangle. And then we looked at some problems where the right triangle is not obvious, but we are able to still construct it and solve for the unknown sides. Now in the previous week, while using the calculator, you may have noticed, or there was a point in the video where we had some negative values come up, and I said to ignore them for now and they would make sense this week. So that's where we're at now. For example, try plugging cosine 120 right here. Cosine 120, not 20, cosine 120 negative half. So make sure it's in degrees. If it's not in degrees, you will end up getting something else, not negative 0.5. Now, which means that there is a broader sort of perspective that can be gained from these three functions. So by restricting them to being lengths of sides, we are sort of we are losing some information. I mean, it's still important because that's the definition. But the fact is we need to explain this using an alternate way of viewing these ratios. To do that, I'm going to introduce a few ideas, which again we're going to revisit in the last week's material when we talk about vectors. This idea is that of a Cartesian coordinate system. And this is not, what do you say, specific to mathematics, right? When we traverse our everyday world, even like, so thousands of years ago, we always want a notion of direction, right? So we have north, south, east, west, or we know, for example, there is a notion of moving forward and a notion of moving backwards, which are sort of inverses or opposites of each other. And we have a notion of moving left and right, and going from a point to any other point is just going right and up, right and up, right and up, or going up and right, up and right, up and right, right? So any motion can be established as a movement along two directions. And that's why this direction is, the system is called a rectangular coordinate system. This is called the x-axis, this is called the y-axis. Now specifically this point O is called the origin, that's the point 0. Now on the right branch here, these are positive x values. On the left branch is negative x values. The intuition coming from the fact that if you start from a point and you go right and then you come back left, you're at the same point, so your displacement is 0. That's why moving left is negative. Similarly, if you go up and then you come back down, you're at the same place. So this is said to be positive y and this is said to be negative y. That is the sort of intuition where origin is sort of like your original state, right? Okay. Now that we have the system in place, we need to somehow put a right triangle in there and look at the nature of these ratios. Now what I'm going to do here is I'm going to put a circle. Okay. Now there are some nice things associated with the circle, and that's why I'm putting in a circle. Now take a point P and I can create this right angle where this is the radius. Now this is again not new because we saw this in our analysis of sine and cosine values, right, as ratios of sides of this triangle. So we're going to do the same thing here, but instead of looking at the values, we're going to look at the sign of the ratios. I'm going to do that, it's on the next page, but let's see what was happening here. For 120 degrees, you always start here, right? So you go from here to here, that's 90 degrees. So 120 puts you somewhere here. Right, that's 120 degrees. Now if you look at this right triangle here, and cosine is opposite adjacent over hypotenuse. The hypotenuse is a radius, it's positive, but this length here, or this side here, is on the negative. And when you divide a negative by a positive, you end up with a negative number. So that sort of explains why this has to be, or this comes out to be a negative value. So so one of your worksheet problem is to extend this to quadrant 4. I'm going to go through 4 quadrants for the 3 functions. So quadrant 1, this means I have a circle, I have a point somewhere here. This is positive, and this is always positive. So my ratio values, sine is what is it? Opposite over hypotenuse, so it's positive over positive, it's positive. Adjacent over hypotenuse, positive over positive is positive. Tangent is opposite over adjacent, positive over positive. So the conclusion here is all positive. Oops, I guess I made these so that I would show this was supposed to be for cosine and tangent, but no, I did it in one diagram. Quadrant 2, so let's put a point here. Let me use the spaces I've created here. Okay, that's there. This negative, positive, negative, positive, negative, positive. So sine, opposite over hypotenuse, so that's my angle, right? Positive over positive, positive. Cosine, adjacent over hypotenuse, negative over positive is negative. And tangent is opposite over adjacent, which is positive over negative, which is also negative. So sine is positive. The second quadrant, sine is positive. First quadrant, we can say all positive. Third quadrant, that's right here. That's negative, and that is also negative. This is positive. Negative, negative, positive, negative, negative, positive. Now, they are both negative because you're on this side, which is the negative x-axis, and this height is on the negative x-axis as well. So sine is going to be opposite over hypotenuse. The hypotenuse is always positive because it's a distance there. What's opposite? That's the angle here. Negative over positive, negative. Is adjacent over hypotenuse, negative over positive, negative. And tangent is opposite over adjacent, negative over negative, which is positive. So third quadrant, you get that tangent is positive. Now similarly, I want you to try for the fourth quadrant. Actually, maybe just back up a little bit, and when you have these coordinates, you create these 4 spaces, and these are called quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and they're always counted counterclockwise or anti-clockwise. Another way of numerically talking about these quadrant is between 0 degrees and 90 degrees is quadrant 1. Between 90 degrees and 180 degrees is quadrant 2. Between 180 degrees and 270 degrees is quadrant 3. And between 270 degrees and 360 which equals 0, is quadrant 4. Remember, 360 degrees and 0 degrees coincide because 360 degrees is one full rotation. And when you take a one full rotation, you end up exactly where you started. So when I say quadrant 4, try it yourself. That means your triangle is somewhere here. So you need to figure out if x is positive, y is positive, which ones are negative, and based on that, which ratio comes out to be positive or negative. Now, in the end, what you should end up with is this rule which tells you what is positive in which quadrant. So remember, all positive in quadrant 1, sine positive in quadrant 2, tangent positive in quadrant 3, and you should end up with ASTC. There's a bunch of ways you can remember this acronym. When I was a student, one of the acronyms that was used was it was called After School to Coffee. Then when I started teaching, another one that I heard was all students take calculus, which obviously is not a true statement, but well, if you can remember it. So basically what it says is it goes ASTC for each quadrant, meaning all positive in first, sine positive in second, tangent positive in third, and as you hopefully will figure out, it'll come out, the fourth quadrant is cosine positive. Now also remember, the reciprocals are also positive, right? Sine positive means, so sine positive also means cosecant is positive, right? Because if a number is positive, then 1 divided by the number is positive. If a number is negative, so if cosine is negative, then secant will be negative, because 1 divided by a negative value is negative. Okay, so on the worksheet you'll again have to sort of explain why whatever you get for the quadrant 4, which should be cosine positive. And yeah, that's it for the first video for day 2.